Let's continue our derivative rule with the review with the product rule. So if we have two things multiplied together and we're taking the derivative, we take the first function exactly as it is, times the derivative of the second function, then we add the second function times the derivative of the first. Do note there will be some problems like this one where yes, you could multiply first and then do the derivative, but there will also be problems where that is not an option. So let's go ahead and practice with this product rule. So I'm going to take the first function exactly as it is, and then multiply by the derivative of the second one. And then I'm going to add the second one exactly as is, and multiply by the derivative of the first. So that is just writing out what my product rule is. So let's go ahead and finish those derivatives. The derivative of 3x squared minus 1 is 6x. And then the derivative of 2x plus 3 is 2. So there is my unsimplified derivative. Now the rule of thumb I'm going to use for this class is if you have binomials or lower, so no trinomials or higher, then please do distribute out and simplify. So here I would like to go ahead and finish simplifying that. So I will get 12x squared plus 18x, and then distributing in the second one, I'll get 6x squared plus 2, and then adding up all my like terms, I get 18x squared plus 18x plus 2. I'm not going to worry about factoring that. I'm going to go ahead and keep that answer as is. So that is my product rule. Now let's look at our quotient rule, so where I've got division. So formally, I've got the denominator as is, times the derivative of the numerator, minus the numerator as is, times the derivative of the denominator, all over my denominator squared. If I think of my numerator as high and my denominator as low, and everywhere I've got a d there, that means the derivative, I can think of it as low d high minus high d low all over low low, which is a little easier to remember. Now the product rule, since it was a plus, if I did these in a different order, it would not matter. But the quotient rule has a minus sign in it. So it is important that we start with the denominator. That is going to make a difference here. So we will have to be more careful with the quotient rule. So let's see an example. So again, let's just write out what that quotient rule is. So I've got the denominator as is, times the derivative of the numerator, minus the numerator as is, times the derivative of my denominator, and I put the whole thing over my denominator squared. So again, I like to take a step and just write what that quotient rule is. Now, if you can skip that step, that is perfectly okay, but I like to write it out. All right, let's finish taking those derivatives. So the derivative of 2x minus 1 is 2, and the derivative of 4x plus 3 is 4. And let's scooch that up. So there's my unsimplified derivative. Now, just like with the product rule, if I can, or if I have binomials or lower, I would like to go ahead and distribute them out. We've got to be a little careful here. I am distributing the 4, but I am also going to distribute that negative sign. So I'm going to get 8x plus 6 minus 8x plus 2. So be careful with that negative sign. Again, that is a place where students get into trouble. Now this will often happen. I have terms that cross out and terms that I can add up. So here I do just get an 8 on the top. You'll notice I left my denominator as a quantity squared. I will not expect that you square that out. It is perfectly okay to leave it in that form. And that is my quotient rule. Let's also do the chain rule. So here we have a function inside of a function. So our formal chain rule, we're taking the derivative of the outer function, leaving the inner function as is there, but then we're multiplying by the inner function. Now most of our problems will be in the form of a function raised to a power, so we sometimes call this the extended power rule. So I bring the exponent of 2 out in front. I leave that function f of x as is, subtract 1 from the exponents, so that looks like the power rule. But then I also multiply by the derivative of the inside. Now that second version matches my problem here, so that's what I'm going to go ahead and do as I work through this. So I'm going to bring the 8 out in front, I leave the inside the same, subtract 1 from the exponents, but then I need to multiply by the derivative of the inside. So finishing that derivative, I will get 2x plus 5. Now if this was a monomial, a single term, I'd go ahead and multiply it up in the front with that 8 to simplify. But generally if I have a binomial or higher, I am just going to go ahead and leave that as is. And that is the final answer I'm looking for. So that is my chain rule.